Hi, in this video we are going to discuss about the performance metric. Basically, first question we have to know why we need this performance metric. For suppose let's take an example. We have a binary classification data and we train three different models. Let's suppose KNN, logistic regression LR and SVN. After training, at the end of the deployment, we have to consider only one model for the deployment, but we are not going to consider three models for that one. We have to pick one of the model from these three models. How we can pick is based on the performance metric. Okay, the which model giving the highest performance. By using metric, we will find that one. We will use that model for the deployment purpose. That is the thing here. And we have different performance metrics are there based on the it's a classification task or the regression task. For the classification task we have the accuracy and the confusion matrix. From the confusion matrix we will get the true positive rate, false positive rates like that, and also precision, accuracy, F1 scores and AUC and ROC scores, and log loss also for the classification task. And these are the for the classification task. And for the regression task we have the R square and mean square error like that. We have those performance matrix. By using this performance matrix we are going to pick one model. We'll check the performance of the different models on a single data and finally pick a model that will best fit model to the our data. Let's start with accuracy. This was a simple one for the binary classification. No, for the classification task. Accuracy is the ratio of total number of points correctly classified to the total number of points in the data. Number of correctly classified total number of points. And also we can use 100 to get the percentage like that. This is the accuracy. Let's see something. Suppose we have 100 points are there and this 90 are correctly classified. Let's suppose take 80. Then accuracy is equal to 80 by 100 into 100. 80% is accuracy that we get here. Let's see some disadvantages also is there for the accuracy. Let's see those things also. Basically we have more problem when we have data is imbalanced data. Imbalanced data means for suppose we have for the positive class we have 90 points are there and for the negative class we have 100 points are there. Suppose now a model like logistic regression LR model is there and this model classify these 1000 points are positive class only. Suppose okay, at that time what we will get accuracy. By the general observation we can tell it is only classified as a positive class means this is not a good model. By sense we can tell because it is not able to get the negative classes. The accuracy that we will get here 900 is the total number of correctly classified because 100 points are positive means this 900 is actually positive. By this way 900 is the number of correctly classified. Total number is 1000 into 100. Here you will get 90% is accuracy. Wow. Even the model is not better model by the sense, but accuracy we are getting the 90%. Okay, this is the problem with the accuracy. Mostly when the data is imbalanced data. Why we are getting like this? Because basically here we are using the only correctly classified points. That's why we are facing this issue here. To overcome this, are going to use the confusion matrix. Let's go with the binary classification data. Let's suppose we have a task of binary classification, and also we can extend this one to multi-class classification. 0 is a negative class and 1 is positive class. Let's consider like that. This side we are going to actually this 0 and 1. In the down we can use predicted 0 1. Let's start A B C D. Here A represent the predicted is 0 and actual also 0, and B represent predicted is 0 and actual is, that means number of points predicted as 0 and actually is 1, and C represent the number of points predicted as 1 and actually is those points 0, and here D represent the actual predicted is 1 and actual also 1. Now let's go some terminology we are using the confusion matrix. This will be called as true negative. I will use different color. True negative because 0 is a negative class and also predicted is 0 negative and also actual also negative. That's why it is true negative. And here the predicted is negative, but actually this is a true false negative. Here predicted is positive, that means positive, but actually these are the negative, that means false positive. Here predicted is positive, but actually is positive only, that means true negative because it was actually negative and predicted also negative. This one is false negative because predicted is negative, actual is positive. Here predicted is positive, actual is negative, that means false positive. This one is true positive, like that one. Let's go with an example to get more things. Let's have y and y hat here, and the values we got like this 0 1 1 0 1 0 1 1. Let's like this. Predicted let's go with 1 0 1 1 0 0 0 1. Let's take like this. Let us first start with we'll take another color. Predicted is 0 and actually is 0. Predicted 0 is all the predicted zeros. This predicted 0 actually also 0. This only 1 is there. Here the value of 1. Now predicted 0 but actually those value 1. For this one and this one and this one. Here we have 3. Now predicted is 1, actually is 0. Predicted 1, these are the predicted ones. Actually 0. This one and this one, this 2. Here we have 2. And next one, actually predicted 1 and also actually also 1. This one and this one, 2 here. For the true negative we get 1 point and false negative we get 3 points and false positive we get 2 points. True positive is 2. These are the values that we got for the. From the confusion matrix we also get few more things. In this let's see few more about true positive rates and false positive rate, true negative rate, false positive rate. There are four different kind of values that we will get from the confusion matrix. They are more useful to check the performance of any model. Let's go with those things. Yeah, here we can call this as positive points, because actually these are the positive points. P equal to false negative plus true positive. This column we called as negative, because actually those are negative. N is equal to true negative plus false positive. Now find the true positive, true negative values. True positive rate is equal to true positive by the positive. Okay, how much we will get here? Let's take true positive is 2. 2 plus 3 5. And now true negative rate. True negative rate is equal to true negative by negative. True negative is 1, and true negative rate is sum is 3. Now false positive rate. False positive by false positive, this one, and by the n. Here also 2, false positive 2, and sum is 3. False negative rate. False negative by false negative here by the positive. False negative is 3 by 5. To tell the generally a model is good model, we have to get the higher values for the true positive and true negative rate, and lower values to the false positive, false negative rate. Here we can observe that we are get the less values to the true positive rate and true negative rate, and the higher values for the false positive, false negative rate. This model is not good model. Let's see 3 more metrics: precision, recall, and F1-Score. These are also most widely used metrics to check the performance. Let's start with precision. Precision is actually predicted positive and true positive. Predicted positive and actually positive means true positive by the predicted positive. Predicted positive means sum of these 2 points. False positive plus true positive. This is the thing about the precision. Recall. Recall is true positive by the actually positive. Actually positive means false negative plus true positive. Let's go with an example to get more understanding about this one. Okay, suppose we have y and y hat. Here we have 0 1 0 1 1. Suppose we have data is like this. For the precision is first we have to find the denominator. The denominator is predicted as positive. These 3 are predicted as positive, in which actually true is this point only. Sorry, these 2 points are true. That means precision is 2 by 3 here. Now for the recall, here is actually true. The denominator is actually true means these 3 are true. These 3 points, and predicted also true is these 2 points only. Here also 2 by 3. Now F1-Score. F1-Score is the harmonic mean of these 2 things. Okay, it's like is equal to 1 by 2 into 1 by precision plus 1 by recall. So here we have 1 by 2. By this way we will get the 2 into precision into recall by precision plus recall. This is the F1 score. Here why we need the F1 score is it is a harmonic mean of precision and recall. If both values are increasing, then we can tell F1 score is going to be increased. These are all the things about the precision and recall and the confusion matrix. In the next video we will discuss about the AUC ROC score and also log loss.